The certification of the European EGNOS service in 2011 as a SBAS system for augmenting satellite navigation, GNSS, has opened up the possibility to construct an approach using vertical guidance, APV SBAS, at a wide range of airports. Such implementation is inexpensive because it does not require any ground-based radio navigation infrastructure. It could be expected that VFR airports would have the greatest interest in such approaches as there is an opportunity to extend the operating conditions by IFR. Experience shows, however, that in many European countries this is hindered by a wide range of circumstances, and therefore the greatest advantage is using a RNAV GNSS approach attained by other categories of airports. First, there are large IFR airports that have ILS, VOR, NDB available, and in accordance with ICO requirements, they obtain an easy and inexpensive backup procedure for airliners by constructing a LNAV VNAV approach. Besides a minimal impact on operations during ILS maintenance, they are also preparing for the gradual shutdown of some ground facilities that are at the end of their service life. Secondly, some IFR airports have published non-precision NDB, VOR, localizer instrument approaches, and adoption for an LPV approach allows them to lower the minima to the level of ILS Category 1. The decision height chosen as a compromise, left at the NPA level, eliminates the need for investment into an approach lightning system. Even in the case of identical or higher minima, the APV approach has many advantages over the NPA, such as vertical guidance during descent, a more stable guidance in general, and reduced risk of a controlled flight into terrain. The last group are controlled VFR airports trying to introduce IFR traffic using an RNAV GNSS approach with LPV minima and other approaches. This could be the way to attract smaller operators. For this to happen, a number of issues must be resolved. Airspace classification. Since most of the airports considered are surrounded by Class G airspace, it is necessary to resolve the concurrent VFR and IFR traffic in it. One option is to set up a traffic information zone, TIZ, around an uncontrolled airport. Communication with the AFIS would be mandatory, and an IFR approaching flight would be allowed to enter the TIZ with the approval of the Flight Information Service before reaching the minimum radar vectoring altitude. This would guarantee that there will only be one aircraft flying IFR in the traffic zone, and there will be no need to maintain separations for an instrument flight. Another problem is the runway marking and lighting requirements, including the approach light system. Finally, the certification of an uncontrolled airport with an AFIS service for IFR traffic and the procedure certification. The existence of originally VFR airports where RNAV GNSS procedures have been implemented proves that the problems can be solved. Higher availability of airports for IFR flights is a prerequisite for increased safety and traffic efficiency.